Let me walk you through the graphing of radical functions by identifying the key points and the basic shapes of square roots and cube roots. Remember, you can use the basic shape of the parabola, the square function, which you know by the pattern vertex, and then up 1, up 3, and up 5, left and right with each step. You can use that basic pattern to look at the first square root shape, y equals the square root of x. It's literally half a parabola on its side. And so every time we go up 1, we go right 1, then up 1, right 3, and then up 1 and right 5. So there's a basic square root shape, vertical at the beginning, then gently curving through these 4 significant dots. If you translate the square root shape, say the argument is x plus 5 instead of x, you still want to identify the places where the square root gives you 0, 1, 2, and 3. And that still requires the inside of the square root, the argument, to be 0, 1, 4, or 9. But the only difference now is you have to calculate what x values produce 0, 1, 4, or 9. So x plus 5, for example, is 4 when x is equal to minus 1. When you plot these values of x with the 0, 1, 2, and 3, it gives you the same parabola shape and the same right 1, right 3, right 5 pattern, but the whole shape has been moved 5 units to the left. It's been translated 5 units to the left. If you have a linear argument, not just a simple translation, you can still use the same technique. You want to have the values 0, 1, 2, and 3. You need to insert 0, 1, 4, and 9 into the square root. But now you can find out what values of x produce the 0, 1, 4, and 9 by solving some linear equations. Calculate the fourth value yourself. But when you plot these, you see that you still have the 1, 3, 5 pattern, except now you're moving over 1/4, and then 3/4, and then 5/4, because of the 4 in front of the x. So these values in the x column are not random. If you have an argument 2 minus 3x, set up the same table, but what's the effect of the minus sign? Now you're going to see when you plot these points, after you figure out the x's you need to plot these points, that you're going to go left 1/3, then left 3/3, then left 5/3. In other words, the whole square root shape is growing to the left. Use the same technique to do cube roots, except in cube roots you're going to identify 5 key points based on 5 simple perfect cubes. And then if you have an argument that's more than a simple x, you can use this 3-column table to find out what x's produce the values of x minus 2 that'll give you these perfect cube roots. In this case, we've moved the cube root shape 2 units to the right. If we have a different argument inside the cube root shape, we can make the same table and have the same pattern. Notice how I move over 1/3 and then 7/3, and on the underside back 1/3 and back 7/3. That's using the basic cube root pattern of 1 over and 7 over, 1 back and 7 back. If you have a more complicated function inside the cube root, you still create this table. Here I'm going to count by force, and I create a cube root shape that's backwards, but still 1/4 left and right, and then 7/4 left and right. What's the story? Know the key points of your shape, and you can draw any shape. Choose the scale on your axes that makes your key points easy to plot. Do a few simple algebraic calculations to find the good values of x to use in your plot.